Good morning everyone. My name is Teacher Deo, ang teacher na nagpapasabog ng kaalaman. Our lesson for today is all about frequency distribution under graphic representation. Once again, our lesson for today is frequency distributions under graphic representation. Teachers have many tasks to do, from planning the lessons, appropriate items to be used. We also need to consider what technique or strategies in implementing the lessons so that the knowledge will be gained by the learners and a lot more to do until the exam will be administered to the students. After it, we must assess the result of the examination of the students, wherein teachers must, number 1, know how to classify, tabulate, analyze, and interpret the scores obtained by students, and number 2, know the appropriate statistical tools and procedures to apply. The scores collected from assessments are arranged in methodical order by grouping them in classes in a form of frequency distributions. Frequency distributions is applicable when the number of cases n is 30 or more. Example of this is when you have 30 or more students who take the exam. We can use frequency distributions. It is also known as group data. While if we have below 30 students who take the exam, we can use the simplest statistic tool or known as ungrouped data. Look at the example. It is the scores of 50 teacher education students in a 110-item test and assessment of student learning 2 in a certain state university in Metro Manila. It is only an artificial data. You have 50, 85, 90, 98, and so on. Generally speaking, frequency distributions is any arrangement of data that shows the frequency of occurrence of different variable or frequency of occurrence of values falling within arbitrarily defined ranges of the variable known as class interval by Ferguson and Takani, 1989. Let's look at the table once again. We can start by asking how many students got the score of 70, 71, 72, and so on. But this question does not give adequate information because in a group of 50 students whose scores range from 48 to 49, many scores do not occur only once. Hence, arrangement of scores in a form of frequency distribution is needed. So are you ready, guys? Because we will start now the challenging parts where you can see afterwards that it is a piece of cake. Steps in arranging scores in a form of frequency distribution. Step 1. Find the absolute range, wherein range is equal to highest score minus LS lowest score. Let's go back to our table. We must find first our highest score and lowest score. Okay, what is our highest score? You are correct. It is 98. Now, Find the lowest score. Yes, it is 48. So, we substitute our given to our formula, which is R equals HS minus LS. Let's substitute now our given. R equals HS minus LS. R equals HS, which is 98, minus LS, which is 48. So 98 minus 48 is 50. So our range is 50. Step 2. Find the class interval. Divide the range by 10 and by 20 such that the class limits are not less than 10 and not more than 20, provided that the class covers the total number of scores. Let's do our illustration. What is our range again? Yes, it is 50. Step 2 said that we must divide our range by 10 and by 20 to get the class interval. Let's do the 10 first. 50 divide 10 is 5. Next, 50 divide 20 is 2.5. We must round up 2.5 so that we have a whole number 3. Our prospect class interval is 5 and 3, but we must include the class interval that was scooped between on our answer. In our example, 5 and 3, we must include 4 as class interval because it is in the scope of 5 and 3. So, we have 5, 4, and 3 as our prospect class interval. In choosing the final class interval, odd number is preferred. So, we must scratch the number 4 because it is an even number. We do have 2 odd numbers as class interval, but 5 is more preferable as the class interval because class limits will not be more than 20 and not less than 10. We must remember that the ideal class limits is 11 to 15, and if we use 5 as class interval, we can obtain 11 class limits. Step 3. Set up the classes. Add C over 2 or 1/2 of the class interval C to the highest score, 98, and subtract C over 2 to the highest score as the highest class limit. Let's do our illustration. What is our class interval once again? Yes, it is 5. 5 divided 2 is 2.5. We must add and subtract 2.5 to our highest score, 98. 98 plus 2.5 is equal to 100.5. And 98 minus 2.5 is 95.5. Our highest class limit is 95.5 to 100.5. The highest class limit is 100.5 to 95.5. Subtract 5 as class interval from the lower class limit of the highest class, 95.5. Example, 95.5 minus 5 is equal to 90.5. Then, 90.5 minus 5 is equal to 85.5 up to the lowest score. They are called as the real limits. Let's look at the table. This left portion of the real limits is called lower class limit, while the right portion is called as the upper class limit. Based on the guidelines, we must subtract 5 as class interval from the lower class limits of the highest class. 95.5 minus 5 is 90.5. 90.5 minus 5 is 85.5. 85.5 minus 5 is 80.5, and so on, until to the last score obtained by the students. Let's do the same process on the upper class limit. 100.5 minus 5 is 95.5. 95.5 is 90.5. 90.5 minus 5 is 85.5, and so on. Let's count our real limits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. It is ideal class limits if we base it in the guidelines of step 2. To convert real limit to integral limit, subtract 0.5 from the upper class limit and add 0.5 to the lower class limit. Let's look at the table once again. To convert the real limits to integral limits on the left side, we must add 0.5. 95.5 plus 0.5 is 96. 90.5 plus 0.5 is 91. 85.5 plus 0.5 is 86, and so on. While on the right side, we must subtract 0.5. 100.5 minus 0.5 is 100. 95.5 minus 5 is 95. 90.5 minus 0.5 is 90, and so on. Step 4. Tally the score. Taking each score as it comes, locate it in each proper class and tally. After tallying, count the number of tallies in each class and write it in column frequency. Our first class limits are 96 to 100. Let's go back to our first table and count the students who got the score from 96 to 100. How many students got a score of 96 to 100? Yes, you are correct. We have 4 students who got a score of 98, 98, 97, and 96. Next, let's find the student who got the score of 91 to 95. How many students got a score of 91 to 95? Correct. There are 4 students who got a score of 91, 92, 93, and 95. Let's find now the student who got the score of 86 to 90. How many students got a score of 86 to 90? Correct. We also have 4 students who got 86 to 90. They are 86, 87, 90, and 90. The process is the same until at the bottom. In short, 81 to 85 have 5 students, 76 to 80 have 6 students, 71 to 75 have 9 students, 66 to 70 have 6 students, 61 to 65 have 4 students, 56 to 60 have 3 students, 51 to 55 have 3 students, and lastly, 46 to 50 have 2 students. After tallying the classes, we must write the numerical symbol in the column of frequency. Therefore, the tallied 4 is 4, 5 is 5, 6 is 6, and so on. We must also add the column of the frequency so that we know if what we tallied is equal to the number of cases, which in our example is 4 plus 4 plus 4 plus 5 plus 6 plus 9 plus 6 plus 4 plus 3 plus 3 plus 2 is equal to 50. As I said, the tally must be carefully checked if the sum of each class is equal and also to the number of cases. N, or summation of F, which means number of cases N or sum of frequency, is equals to 50. Obtained by cumulating the frequency or successively adding the individual frequency from the bottom for lesser than up to the highest class limit, or start cumulating or adding the frequency from above for greater than up to the bottom. Look at the table. We have two cumulative frequency distribution, lesser than and greater than. We do first the cumulative frequency lesser than. We must start at the bottom to the top. Let's copy first the first frequency, which is 2, and add the next, which is 3, and so on. 2 plus 3 is equal to 5. 5 plus 3 equal to 8. 8 plus 4 is equal to 12. 12 plus 6 is equal to 18. 18 plus 9 is equal to 27. 27 to 6 is equal to 33. 33 plus 5 is equal to 38. 38 plus 4 is equal to 42. 42 plus 4 is equal to 46. And 46 plus 4 is equal to 50. Next is the cumulative frequency greater than. We must start from the top to the bottom. Copy the first frequency, which is 4, and add the next, which is 4, and so on. 4 plus 4 is equal to 8. 8 plus 4 equal to 12. 12 plus 5 is 17. 17 plus 6 is equal to 23. 23 plus 9 is equal to 32. 32 plus 6 is 38. 38 plus 4 is equal to 42. 42 plus 3 is 45. 45 plus 3 is equal to 48. And 48 plus 2 is equal to 50. Overall, we have 50 cases, which is equal to our data in the table. A simple trivia: if you are right-handed, you belong to the greater than symbol, because in statistic, majority of the people are right-handed, while if you are left-handed, you are a lesser than symbol, because only few individuals are left-handed. Last step, solve for cumulative percentage frequency distribution using the formula CPF equals CF over N times 100, whereas CPF is a cumulative percentage frequency, CF cumulative frequency, and N as number of cases. Let's solve first our cumulative frequency lesser than. 50 divided 50 times 100 is 100%. 46 divided 50 times 100 is 92%. 42 divided 50 times 100 is 84%, and so on. Next, we must solve the cumulative frequency greater than. 4 divided 50 times 100 is 8%. 8 divided 50 times 100 is 16%. 12 divided 50 times 100 is 24%, and so on. In summary, frequency distribution is arrangement of data that shows the frequency of occurrence of different variable. It is applicable only if we have 30 number of cases or more. The steps in arranging score in a form of frequency distribution are: Step 1. Find the absolute range by subtracting highest score to lowest score. Step 2. Finding the class interval by dividing the range by 10 and 20, wherein odd numbers are preferred class limits. It must not be more than 20 and less than 10. We must also remember that the ideal class is 11 to 15. Step 3. Set up the classes by dividing the class interval by 2. Then we add and subtract the highest score with the answer in order to set the highest class limit. We must also subtract class interval from our highest class limit until at the lowest class limit to determine the real limit. After it, we must convert real limit to integral limit by subtracting 0.5 from upper class limit and adding 0.5 to the lower class limit. Step 4. Tally the score. After tallying, count the number of the tallies in each class and write the numerical symbol in the frequency column. We must carefully check if the sum of the classes or the number of cases is equal to the data. Step 5. Determine the cumulative frequency distribution. By determining the cumulative frequency distribution lesser than, we must start at the bottom. Copy the first frequency from the bottom and add the next one. The total of the first two data will be added to the third one, and so on. We'll do the same on the cumulative frequency distribution greater than, but we must start from the top to the bottom. Lastly, we must solve the cumulative percentage frequency distribution by using the formula CPF equals CF over N times 100, wherein CPF is cumulative percentage frequency, CF is cumulative frequency, and N is the number of cases. That's all for today's video, guys. I hope ay nakapagbigay ako ng kunting kaalaman. I make this a 2-part video because our first video is mahaba na. The focus of our first video is all about frequency distribution. The next part that will be featured on our next video is all about graphic distribution. If you want to learn the next videos and my upcoming videos, please subscribe on my YouTube channel and please click the notification bell para updated ka lagi sa aking mga future videos. Ako ulit, si Teacher Deo, ang nagsasabing sapat na kaalaman ang kailangan para may maisagot sa iyong module. Tiis-tiis muna dahil balang araw ay nasa sulok na tayo ng ating silid-aralan. Tiwala lang kay God dahil He made a better plan for us. Bye-bye!